The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
In this demonstration, we're going to show the influence of an optical fiber on the polarization properties of light. In this case, we're going to use a normal single-mode fiber. The setup is as shown here. We have a helium neon laser. Here's the beam from the laser, reflected by this mirror here, then by another mirror here, into a quarter wave plate and a polarizer. And in this way, by rotating the polarizer here, I can select any linear polarization I want in this region. Then what we do is we take the light from here, we pass it through a short focal length lens, focus it into the fiber, to the single mode fiber over here, and then the output of the fiber is again collimated by another short focal length lens, and then the output of this lens then we let go onto the screen. So this is the basic setup, and now we're ready to look at polarization effects in fibers. Now first, we have to establish the state of polarization of the light going into the fiber. So what I'm going to do, take this polarizer and place it over here, and then I'll take a card, place it here, and now I want to rotate the polarizer, and the axis, the little white arrow here indicates the transmission axis of the polarizer. So I can rotate polarizer now, and then in this region over here, I have null, which means that the plane of polarization of the light is orthogonal to the direction of this arrow. All right, so indeed we have plane polarized light as indicated by the arrow over here, which is orthogonal to the one here. All right, so now we've established that the state of polarization is linear going in to the fiber. Now let's look at the polarization of the light coming out of the fiber. Again, I'm going to take the polarizer and place it over here, the output. And now let's look at the spot in the inset. Here we have the spot in the inset. Now I'm going to rotate the transmission axis of the polarizer to see what we have. Gee, we have indeed plane polarized light also coming out of the fiber. So we have plane polarized light going in and plane polarized light coming out. Now to demonstrate what the fiber does to the polarization in a very dramatic way, all I have to do is twist the fiber by just pushing on it. And you can see that now, just by applying a little stress to the fiber, now I have changed the polarization, because now I have light coming out of the polarizer, while before it was null. Now again, I can push the fiber around some more, and I can see I can change the amount of light coming through the polarizer, which means that the state of polarization is changing just by simply applying simple stress. I can apply mechanical stress like I'm doing now. I can get the similar effect by heating the fiber, and so on, so that the state of polarization then can be influenced quite a bit by the environment, the effect of the environment on the fiber. You can see here I can make it come out very bright through the polarizer when originally it was null. Here we are, can go to null, 0, which means plane polarized. Now it's some state of polarization. In fact, I'm going to hold the fiber in this position, and then now I'm going to go and I'm going to turn the polarizer to see indeed do I have plane polarized light or elliptically polarized light? Well, it's elliptically polarized light because I can't null it. So now I have changed the state of polarization then from linear to elliptical. And again, if I put more stress on the fiber, let's see now what state polarization I get now. Again, you can see it is elliptical because I can't null it. So in conclusion then, a regular single mode fiber can change the state of polarization of light going into it into almost anything, into plane polarized, circular polarized, elliptically polarized, and this is influenced greatly by the environment that the fiber is in. So it's very difficult to maintain then a good state of polarization or a known state of polarization in a single mode fiber because of these environmental disturbances. If one wants to maintain, let's say, linear polarization, one would have to use a polarization maintaining fiber.